Okay, so I've plugged in some real numbers. I know at first glance the board looks a little busy. We're going to work through it though and help you to understand where the numbers go and the order in which you do this. So I said we have a 250 volt 60 hertz motor, draws 32 amps, and the power factor is 0.65. So I made my first triangle, and the very first thing I can do is put power factor equals 0.65 inside my triangle without any other values applied to it. You go to step 1 on the left side of the board. We know how to calculate VA. That's our voltage times our current. So 250 volts times 32 amps, we get a VA value of 8,000. So I go ahead and I put that on my triangle. Now with my VA and my power factor, like we had done before, we can calculate our watts. So power equals 8,000 VA times our power factor of 0.65. Our power equals 5,200 watts. So I put that on my triangle on the left with power factor 0.65. As soon as I do that, I can right away take that 5,200 watts and I can put it in the triangle on the right without doing anything else. That's my next step. So that 5,200 watts converts right over to that triangle. That's power factor equals 0.9. Now, let's go back to the left side of the board. So we start building a second triangle. We can do one of two things. We can complete the values for our second triangle, which is our corrected triangle, or we can go ahead and find out what the total VARs is for our first triangle. So let's look at step 3. VARs equals Pythagorean theorem, 8,000 squared minus 5,200 squared, our VA squared minus our watt squared. Our VARs equals 6,079.47. We're going to call that value Z, okay? So we have all three sides of our uncorrected triangle applied, completed. We can now go over to our smaller triangle and we can calculate our new VA. So I called that step 4. So in the upper right portion of the board here, we take that 5,200 watts. We know the VA will be bigger than our wattage, so we're going to divide by a decimal to get a larger number. So 5,200 watts divided by our power factor we want to establish or correct to is 0.9. New VA equals 5,777.78. I put that on my triangle. Now I have my watts, I have my VA. I can calculate my new VARs, or the amount of VARs I'll have once I've corrected to 0.9. So that is, again, Pythagorean theorem, 2,518.48 VARs. And I'm going to call that value Y. Step 6, this is where we get to this corrected amount. What size of capacitor in VARs do I need to install in this circuit to get my power factor 2.9? So I want to undo some of the inductive portion of this circuit by adding a capacitor. So I said X, which is the corrected amount, the amount we need to correct, equals our Z, which was our total VARs with the uncorrected triangle, minus our Y, which is our completed triangle, the amount of VARs associated with it. And you can see on the far left bottom of the board, I got Z equals total VARs at 0.65 power factor, Y equals total VARs at 0.9 power factor, X is the amount in VARs needed to correct to 0.9. So if I subtract my Z from my Y, or my Z minus my Y, I get an X of 3,560.92 VARs. So in A, size of capacitor for correction to power factor 0.9 would be a 3,560.92 VARs capacitor. Now, we will get to this step eventually. That is not a typical way that we're going to necessarily size a capacitor. More likely it's going to be in farads or in kVARs. So we could have a 3.5 kVAR capacitor. So I'm going to erase the majority of this on the board, and we will complete B and C. Line current before correction, line current after correction. So you can see the difference in the current that we would have on our conductors feeding the load.